Assalamualaikum and hi, our topic project is stainless steel mechanical properties and structure. So our company name is JAMAL Stainless Steel MOHAMAD. So our staff is JAMAL ZAIM as a project leader, Muhammad Arif as lab operator, Muhammad FAIZ as senior engineer, NAZRIN HAZIQ as our training staff. So our company background, we have over 10 years of experience providing expert in material design and technology solution for civil work. We have done projects with variety of clients such as Petronas, UTEM, and IOI Properties. So our current project right now is Petronas Twin Tower structure design and test. For Petronas Twin Tower, we use materials such as 316 LSS, referred to as E4 stainless steel emery grade stainless steel. Its primary alloying constitute iron, chromium, nickel, and molybdenum with small quantities of silicon, phosphorus, and sulfur are so present. When cold, it can produce high yield and tensile strength similar to duplex stainless steel strips.
Thanks to my friend Jamal. I'm here today to present about standard procedure of tensile test. Before we going further, first of all, we need to understand what is tensile test. Basically, tensile test is to test material strength by using tension method. Secondly, to create stress and strain curve graph when materials react to tensile test. Finally, tensile machine also can generate data and determine mechanical properties from material by using a computer. On the left side in the slide, we can see the scheme of tensile test setup. To start the experiment, you have to follow the correct procedure. First step, measure and record the specimen's dimensions necessary to determine the cross-sectional area. Second step, use ink and a scribe or punch to place gauge marks on the test specimens at the appropriate gauge length. Next, zero the testing machine without the specimens inserted in the grips. Then, install the specimen in the grips and start loading the sample. Then, run the test until specimens fail or fracture. Lastly, record all the data and prepare the full report. I will pass the slide to my friend for the data analysis.
Thank you, Arif. And hi, today I will talk about data analysis. As you can see on the slide, this is the graph for the original 316L stainless steel 2.0 mm. The orange curve is for the stress versus strain. Meanwhile, the green line is the 0.02% strain offset line. Here, you can see the result for yield strength, yield strain, and modulus of elasticity for this graph. Next, this is the graph for cold roll 316L stainless steel 1.0 mm. And this is the result for yield strength, yield strain, and the modulus of elasticity for this graph. As you can see, the value of yield strength for cold roll is higher than the original 316L stainless steel. So now we can conclude that the cold roll is harder, stronger, and higher resistant against tension breaking compared to the original 316L stainless steel. Thank you.
Hi, from this assignment, we can discuss about the difference between the original and Control 316L stainless steel samples. The difference between both samples is original sample has coarse grain structure, while Control sample has fine grain structure. In the table, we can see the optical microstructure of 316L stainless steel before and after cold rolling. From the sample, we can see the original sample has coarse grain, hence its elongation is larger, while cold rolled stainless steel has fine grain, hence its elongation is shorter. Next, cold rolling of material increase number of dislocation in material. Moreover, original sample shows ductile kind of failure fracture dimple are seen from electron microscope for this failure, while for cold rolled sample, surface after fracture is different from ductile fracture sample. Lastly, for ductile cup and cone type fracture occur, and for vital material fracture 90 degree to axial direct occur. And this is the difference between highly ductile, moderate ductile, and brittle.
So for the conclusion, the design we know that Petronas Twin Tower made from 316 LSS and that was selected due to important design criteria like artistic appearance and corrosion resistance. The tower design must be strong while having lustrous sun reflective effect. There are two conditions from 316 LSS, which is when it is normal condition and cold condition. So we know that 316 LSSS has two conditions and make it suitable for Petronas Twin Tower. The 316 LSS is the standard molybdenum grade and importance among the artistic stainless steel. And for our information too, the molybdenum alloying element gives this stainless steel better overall corrosion resistance with the excellent toughness. This 316 LSS help Petronas Twin Tower more strong in future as shown in our report. We managed to settle this report on time and we have already made video to explain more specific about 316